Hello, I'm Dongkai Wang from Peking University. My report is a contextual instance decoupling for robust multi-person pose estimation. This is a joint work with my advisor, Professor Shiliang Zhang. This is the outline of this report. In this report, we focus on multi-person pose estimation. This task aims to detect all person pose in an image. There are two key issues in MPPE, and we focus on how to differentiate different persons. Previous top-down methods separate persons by detecting person bounding box and spatial cropping. Bottom-up methods will first detect all identity-free key points and separate persons by grouping operation. Recently, single-stage regression method detect person local features and directly regress all key points coordinates. The above methods have some drawbacks. For top-down methods, they cannot deal with crowded scenes. Boxes will be surprised by NMS, thus leading to missed person detection. Moreover, there will be more than one person in box, which does not meet the assumption of top-down methods. Bottom-up methods is also prone to crowded scenes. Grouping operation cannot recover the missed key points. They are also complex and slow. Single-stage method is efficient, but they are hard to optimize due to long-distance regression and discard the spatial information in original feature map. So we aimed to propose the contextual instance decoupling as a better way to separate persons. CID decouples each person into different feature maps. The generated feature maps focus on one specific person and preserve rich spatial information to infer heat map, thus relieve the difficulty of regression. At this session, I will describe our approach. We achieve this goal by the proposed CID operation. It contains two parts. Given an image with multiple persons, we first extract the global feature map by CNN. Then an instance information abstraction module is proposed to get the instance feature and locations. These feature and locations are passed to global feature decoupling module to generate different feature maps for each person. Finally, we use these feature maps for heat map estimation and get the post results. So let's look at the first module. I extract features and locations by detecting the person center points. To ensure the discriminative power of person feature to separate persons, we propose a contrastive loss that pushes all person features in an image away. The right figure shows that with such loss, we can separate persons even when they share similar appearance. GFD uses a person feature and location information to generate instance-aware feature maps for each person, and it is achieved by modulating the feature map in spatial and channel dimension. In spatial dimension, we aim to get a spatial mask to downweight the region of either person. We call it as spatial recalibration. It takes the instance relative code map and appearance similarity map as input and output such a spatial mask. In III, we constrain that different person feature is dissimilar, so they have different channel distribution that can reflect their identity information. Therefore, we can modulate feature maps on channel dimension by element-wise manipulation to generate channel conditioned feature maps. And the final feature map can be obtained by fusing the spatial and channel results. Then we use the feature map for heat map estimation and supervise it with ground truth heat map. Next is the experiment section. CID achieves superior performance in general scenes, such as COCO dataset. Moreover, it achieves better performance on crowded scenes, such as crowd pose and UC human dataset. Here we give some visualization results. Our method can differentiate persons in crowded scenes, which is important for robust multi-person pose estimation in real scenarios. Our method also achieved high efficiency, which is faster than most previous methods. So in concluding, we propose a novel MPPE method named Contextual Instance Decoupling, which separates each person into different feature maps for heat map estimation. Our method effectively differentiates persons in crowded scenes and avoid missed key point detection and person detection, achieving promising performance on 3 MPPE benchmarks. That's all. Thank you for your listening.